So today I'm going to solve Leetcode problem number 209, minimum size subarray sum. It's a medium level problem, and the problem is given an array of n positive integers and a positive integer s, find the minimal length of a contiguous subarray, the sum of which should be greater than or equal to s. If there isn't one, we need to return 0 instead. So let's take the given example. So we need to find a subarray. So it can be like 2, 3 or 2, 3, 1, and the sum of which should be greater than 7. So let's take 2, 3, 1. So its sum is 6, which is less than 7. So it's not a valid subarray. And if we take another example, 1, 2, 4. So its sum is 7. So it's a valid subarray. So, a simple solution would be with brute force by considering all possible subarrays using two nested loops. The outer loop picks the starting element, and the inner loop picks all the element to the right of the current start as the end element. And whenever the sum of the elements between current start and end becomes more than the given value s, we update the result value if the length between the start and end is smallest so far. The outer loop picks the starting element, and the inner loop picks all the elements to the right of the current start as the end element. And whenever the sum of the elements between current start and end becomes more than the given value s, we update the result value if the length between the start and end is smallest so far. But this method is not optimal, and it might give us TLE. So the time complexity of brute force would be O of n squared. We can do better with the time complexity of O of n, uh, looping through the array just once. So what we can do is we can use two-pointer technique. So let me explain. So if we will start from index 0, and as we iterate through the array, we will keep on adding the current value to a temporary sum. Let's say we iterate through this array, and we foresee 2, and we add it to the sum, which is initially 0. And then we see 3, so we add that to the sum, so we get 5. So as we keep on adding the current value to a temporary sum, let's just call it sum. So let me define it. In each loop, after adding the value of this current element to the sum, we will check if the value of the sum is greater than or equal to the value s, which is 7 in the given example. So let's define another variable to and set it to maximum integer value, and let's see the result. Result variable, it's gonna hold the minimum size of the subarray seen so far. So let's say we are looping from 2, and we have seen 2, 3, 1, and 2. So the sum is 8. We set the result value equal to the length of the subarray, which is 4. If we get the value of sum to be more than or equal to the given integer s, we will update the result to the minimum value, which is the length of the subarray. And after that, to proceed further and check for these subarrays, we will remove the leftmost value from the subarray. Let's define another variable left, which will keep track of the left pointer. Now we will loop through the array and add the current element value to the sum. And we will check if the value of the sum is greater than the given integer s. So if it is, we will update the result to the minimum value. So what we did here was we took the length of the subarray, that is left, I plus 1 minus left. We did this because it's the array starts from 0 index, and as we subtract the sum, the value of the element from the sum, we also move the left pointer forward. So at the end, we will check if the value of the result has been changed from the maximum integer value. If it is, we return the value because we know that we found a subarray, and if not, we will just return 0.